Okay students, today's chapter is conic section. Here the first conic is circle. We'll discuss the various forms of equations of circles in this session. The first equation of circle is centric form. Here center of the circle and radius will be given, and the equation is x minus h whole square plus y minus k whole square is equal to r square, and the corresponding parametric equation is x is equal to h plus r cos theta, y is equal to k plus r sin theta. Next, third one, diametric form of equation of circle. Here the ends of diameter of the circle will be given. x1 y1 and x2 y2 are the extremities of diameter, and the equation of circle in this case is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. And the fourth one is the general form of equation of circle. It is x square plus y square plus 2gx plus 2fy plus c equal to 0. And in this case, the center of the circle is c is equal to minus g comma minus f, and radius r is equal to square root of g square plus f square minus c. Now some important conditions related to general form of equation of circle. Here the note is condition for the circle to touch x axis is c is equal to g square. Similarly, the condition for the circle to touch y axis is c is equal to f square. And the third one, the condition for the circle to touch both the coordinate axes is c is equal to g square and c is equal to f square. Next, one more form of equation of circle. Here, equation of circle whose center is h comma k, and that circle touches the line ax plus by plus c is equal to 0. And in this case, equation of circle is x minus h whole square plus y minus k whole square is equal to mod of ah plus bk plus c divided by root of a square plus b square the whole square. This is about equation of circle. Second conic is parabola. Here two cases are there. In this table, I will give the observations related to both the equations of parabola. The first case is y square is equal to 4ax, and the second case is x square is equal to 4ay. And the geometrical figure for the equation y square is equal to 4ax is described like this. Here I drawn the parabola whose focus lies on x-axis, and the directrix is x is equal to minus a, and this parabola symmetric with respect to x-axis. If a is positive, then parabola symmetric with respect to positive x-axis, and if a negative, inverted parabola you get. Similarly, for x square is equal to 4ay, I describe the parabola whose focus lies on y-axis, and directrix is a horizontal line, y is equal to minus a. Next, some observations. First one, vertex of the parabola. In both the cases, vertex is 0, 0. Here, this parabola touches x-axis or touches the axis at origin. Therefore, vertex is 0, 0. And in the second case also, the vertex is 0, 0. Next, focus. Focus of the parabola is a, 0, and in second case 0, a. Directrix x is equal to minus a, and in second case y is equal to minus a. Length of the lattice rectum, in both the cases it is 4a. Now, ends of the lattice rectum. The end point of the lattice rectum are given by a, 2a in first case, 2a, a in second case. Next, last one, parametric equation of parabola. It is x is equal to 80 square, y is equal to 280 for y square is equal to 4ax, and for the second case, x is equal to 280, y is equal to 80 square. Okay. Next, third conic is ellipse. Here the important points related to the standard equation of ellipse. Here two cases are there. In first case, the foci of the ellipse lies on x-axis, and in second case, foci taken on y-axis. The standard equation for the first case is x square by a square plus y square by b square is equal to 1, where a greater than b, and for the second case means if foci lies on y-axis, then equation is same, x square by a square plus y square by b square is equal to 1, but a less than b. Here are the two geometrical shapes for the two cases. In both the cases, the center of the ellipse is 0, 0. Next, foci of the ellipse. In first case, it is plus or minus c, 0. In second case, 0, plus or minus 3 because it is on y-axis. Relation between A, B, C. Here, A is length of semi-major axis, B is length of semi-minor axis, and C is the distance between center and one focus. The relation between A, B, C. In first case is A square is equal to B square plus C square, and for the second case, B square is equal to A square plus C square. Next, eccentricity of an ellipse. E is equal to C by A for the first case, or using above relation, C by A is equal to square root of 1 minus B square by A square, and this value will be less than 1. Second case, E is equal to C by B, or 1 minus root of A square by B square. In both the cases, eccentricity of ellipse is less than 1. Next, sum of the focal distance. The sum of distance between any point on ellipse and the two foci, Pf1 plus Pf2 is equal to 2a, and in second case, Pf1 plus Pf2 is equal to 2b. Length of the lattice rectum, 2b square by a in first case and 2a square by b in second case. Ends of the lattice rectum, it is c, plus or minus b square by a, or here plus or minus a square by b, c. Next, vertices of the ellipse. Vertices of the ellipse are, in first case plus or minus a, 0, in second case 0, plus or minus b. Length of the major axis is 2a, length of minor axis is 2b. Next, parametric equation of ellipse. For both the cases, it is x is equal to a cos theta, y is equal to b sin theta. Next, fourth conic is hyperbola. Here also, like ellipse, two cases are there. In first case, the foci of the hyperbola taken on x-axis, and in second case, foci lies on y-axis. For the first case, the standard equation is x square by a square minus y square by b square is equal to 1, and for the second case, y square by b square minus x square by a square is equal to 1. Next, the geometrical figures are like this. In first case, the foci lies on x-axis and parabola symmetric with respect to x-axis, and here hyperbola whose foci are y-axis and symmetric with respect to y-axis. In both the cases, the center of the hyperbola at 0, 0. Next, foci of the hyperbola. The coordinate of foci are plus or minus c, 0, and for next case 0, plus or minus c. Next, relation between A, B, C. Here, A is the half of the length of transverse axis. Next, B is the half of length of conjugate axis. C is the distance between center and one focus. C square is equal to A square plus B square. It is same for both the cases. C square is equal to A square plus B square. Eccentricity. E is equal to C by A, or using above relation, it is square root of 1 plus B square by A square, and this value greater than 1. Eccentricity of hyperbola is more than 1. In next case, E is equal to C by B, or square root of 1 plus A square by B square. Next, difference of the focal distance. Pf1 minus Pf2 is equal to 2a. Here Pf1 minus Pf2 is equal to 2b. Next, length of the lattice rectum. In first case 2b square by a, and in second case 2a square by b. End of the lattice rectum. The endpoints of the lattice rectum are given by c comma plus or minus b square by a for the first case, and for the second case it is plus or minus a square by b comma c. Next, vertices of the hyperbola plus or minus a comma 0 in first case, and for second case 0 comma plus or minus b. Next, parametric equation of hyperbola. X is equal to a secant theta, y is equal to b tan theta. Thank you.